Welcome to the CompTIA A+ Prepcast presented by baremetalcyber.com. Internal display components play a critical role in how mobile devices function beyond simply rendering images. Devices such as laptops and tablets often include complex layered assemblies that incorporate inverters, cameras, microphones, and digitizers. Each of these components serves a unique purpose and may fail independently of the display itself. On the A+ exam, candidates may encounter questions about identifying these components, understanding their function, and troubleshooting related symptoms. Recognizing how they work together ensures a comprehensive understanding of mobile device repair. An inverter is a power conversion component used in older LCD panels that rely on cold cathode fluorescent lamps for backlighting. These inverters transform low-voltage direct current from the laptop's power supply into high-voltage alternating current required by CCFL backlights. Without the inverter functioning properly, the display will not receive the power necessary to illuminate the screen, even if the image is being generated correctly by the graphics subsystem. Understanding the purpose of the inverter is especially important when servicing legacy equipment that predates LED backlighting. A failing inverter typically presents with distinctive symptoms. These may include a screen that flickers intermittently, appears extremely dim, or seems to be off entirely, even when the device is powered on. In some cases, users may still see a faint image if the display is viewed under strong ambient lighting, indicating that the backlight, not the panel or graphics chip, is at fault. Inverter replacement is often the preferred repair method in these situations, restoring the display to full brightness and eliminating flickering. Modern LCD panels have largely eliminated the need for inverters by replacing CCFL backlights with energy-efficient LED lighting. Because LEDs operate on DC power, no inverter is needed to convert voltage. This simplification has allowed manufacturers to design thinner, lighter, and more power-efficient displays. Despite being largely phased out in new devices, inverters are still testable knowledge on the A+ exam. Candidates should be familiar with both legacy systems and current technologies, especially when troubleshooting devices with uncertain age or specifications. Another common internal display component is the integrated webcam, typically accompanied by a small microphone. These components are embedded in the bezel of the laptop display, usually near the top edge. Their location allows for optimal viewing angles during video conferencing, authentication via facial recognition, and general media capture. These cameras may also be paired with physical shutters or LED indicators for privacy assurance, making them a key component in modern security-focused mobile computing. Troubleshooting integrated cameras involves a combination of hardware and software checks. Technicians should begin by confirming that the camera is recognized by the operating system, which can be done through the device manager or equivalent utility. Privacy settings should be reviewed to ensure the camera is not disabled by software policies or user preferences. Some laptops include physical switches or BIOS options that disable the webcam for security reasons, which can lead to confusion if not clearly labeled or documented. The digitizer is another critical component found in touch-enabled displays. Positioned directly above or below the main display panel, the digitizer converts user interactions such as taps, swipes, and gestures into digital input signals. These signals are then processed by the operating system as commands. Without a functioning digitizer, the display may still show a proper image, but it will not respond to any touch input. Digitizers are essential for touchscreen laptops, tablets, and hybrid devices that rely on user interaction through touch rather than traditional input peripherals. There are two major types of digitizers: active and passive. Passive digitizers are responsive to general touch input and are commonly used in smartphones and consumer-grade tablets. Active digitizers, by contrast, work with a specialized stylus and can detect levels of pressure, tilt, and precision. Devices with active digitizers are typically designed for tasks like note-taking, drawing, or professional design work. Some touchscreen displays combine both passive and active technologies, allowing users to interact with fingers or a stylus depending on the context. Symptoms of a faulty digitizer are easy to distinguish from standard display failures. If the screen image is clear but does not respond to touch, or if input is erratic and inaccurate, the digitizer is likely to be the problem. Touch may only work in certain sections of the screen, or multi-touch gestures may fail to register. Calibration may temporarily resolve minor issues, but complete failure often requires the replacement of the entire display assembly, especially in modern devices where digitizers are fused to the screen. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Replacing a faulty digitizer is a detailed and often delicate procedure, particularly in modern mobile devices where the digitizer is fused directly to the display panel. This integration improves responsiveness and reduces overall device thickness. But it also means that a failed digitizer may require replacing the entire display assembly. The process typically involves carefully removing the front bezel, disconnecting ribbon cables, and releasing adhesive that secures the display layers. Heat guns or adhesive separators may be required, and great care must be taken to avoid damaging the screen or internal sensors during removal. Internal display components such as digitizers, webcams, and inverters connect to the mainboard using flat ribbon cables. These cables are thin and fragile, making proper handling critical during disassembly and reassembly. Inverters may use standard 2-pin connectors or proprietary multi-pin plugs depending on the manufacturer. Digitizers and webcams often rely on ZIF, or zero insertion force, connectors that must be unlocked before removal. Mishandling these cables or connectors can result in intermittent function or complete failure of the component. Display hinges are more than mechanical supports. They often serve as pathways for internal wiring. Integrated camera, microphone, and sometimes digitizer cables route through the hinge assembly to reach the motherboard. Repeated opening and closing of the device can place stress on these cables, and over time, pinching or fraying may occur. This can lead to intermittent device recognition or sudden failure of display-adjacent components. Older laptops are especially prone to hinge-related wear, making inspection of hinge wiring an important troubleshooting step. BIOS or UEFI settings may affect whether internal display components function correctly. Integrated webcams and touchscreens can often be enabled or disabled through firmware settings, especially in enterprise environments with heightened security requirements. These settings are usually accessed during the boot process and may not be immediately visible to users unfamiliar with system firmware interfaces. A disabled component may still appear to be installed in the device manager but remain non-functional until enabled at the firmware level. Diagnosing issues with webcams and digitizers requires a combination of software and hardware testing. The device manager should be checked to confirm hardware detection and driver installation. If the device is recognized but not functioning, reinstalling drivers or testing the component in a live operating system environment may help identify the root cause. For digitizer issues, using an external mouse or keyboard can help determine whether the touchscreen failure is isolated or part of a broader system problem. Internal display components are highly sensitive to environmental factors and improper handling. Static discharge, excessive pressure, or incorrect disassembly techniques can cause irreversible damage. Over-tightening screws near the display can crack the digitizer glass or damage internal sensors. Liquid exposure is also particularly hazardous, as it tends to infiltrate bezel openings and pool near vulnerable components like microphones and touch-sensitive surfaces. Awareness of these risks is vital during both servicing and everyday use. After replacing a digitizer, performance must be tested thoroughly. Most manufacturers offer diagnostic tools or calibration utilities to ensure the digitizer is responding accurately. Tests should include swiping in all directions, performing multi-touch gestures, and checking edge responsiveness. Any section of the screen that fails to register input may indicate misalignment or incomplete connection. Confirming full-screen functionality is essential before returning the device to a user or marking the repair as complete. Internal display designs vary significantly between manufacturers and even between models from the same brand. Some systems use modular components that are individually replaceable, while others integrate the screen, digitizer, and bezel into a single unit. The repairability of a device often depends on how the components are fused and whether access panels exist. Manufacturers' service manuals are essential for proper disassembly and reassembly, as screw placements, cable routing, and adhesive use differ widely across models. Sourcing compatible replacement parts requires precision and attention to detail. Technicians must identify exact part numbers or match components based on laptop model identifiers. Connector types, display resolution, and panel technology must all be compatible for the new component to function correctly. Even if a part fits physically, electrical mismatches can result in failure or partial functionality. Verifying compatibility through manufacturer documentation or trusted suppliers is necessary for successful repairs. In summary, internal display components such as inverters, cameras, and digitizers are essential to mobile device operation and appear across multiple exam objectives. These parts may fail independently of the display panel and require specific troubleshooting, safe handling, and careful replacement. The A+ exam expects candidates to understand component function, recognize symptoms of failure, and follow appropriate repair procedures. Mastery of these concepts prepares learners for real-world mobile device support. Thank you for listening. Please visit baremetalcyber.com for more cybersecurity information, podcasts, books, and more.